All right, guys, so today we're going to go over the results from the most recent batch of testing. This is Room EQ Wizard. On the left, you can see all of the different products that we've tested are all named. And then at the bottom, you can toggle on and off each measurement. Red is always going to be untreated, blue will be treated, green will be treated on a different version. So that first one was the Tesla product. This one that I'm showing now is the Digital Designs Audio. This next one is Vibrofiltr 3mm. This one is going to be Resonix. And then we've got Resonix Mega. And then as an addition, I did a modification with Resonix, so I'll show you that when we get to that. So from here, the next one is going to be a product called Audio Additives. It's a 3M made product that's marketed towards home audio. There's also some catches with that program. So one of the things we're going to do is we're going to go ahead and zoom in now. If you notice, nothing much is really happening above 500 hertz or below 50 hertz. So we're going to go ahead and zoom in. Started at 50 hertz, we'll go to 500 hertz, and then we'll raise the bottom end up to about 50 decibels. That'll give us a little bit better view of what we're actually looking at. So again, we're going to go back to this supposed Tesla product. This was sent to me by someone who says it's right off the Tesla factory line. Essentially what you're seeing here is the difference in frequency response between an untreated test panel and the same panel treated with a 25% coverage dead in the center of this Tesla product. You can see that it drops about 9-ish decibels. And you can see that there's a drop in actual frequency of the resonance from the initial measurement. And then if you look around at the other areas, you can see that it doesn't do a whole lot aside from that main resonant frequency. There's a little bit of an increase in amplitude below, a little bit of decreases here and there above the main resonant peak, but realistically, these products are aimed at the resonant frequency. So we're going to go ahead and move on to the Digital Designs Audio now. This is a textured product, just like the Vibrofiltr. Again, we've got a noticeable drop in the actual resonant frequency. And then we've got a drop in amplitude of about 13.3 decibels from untreated to treated. So from here, we're going to go ahead and go to Vibrofiltr. This is their 3mm product. Again, we can see there's a drop in the actual resonant frequency itself. And then this one has a reduction in amplitude of that resonance of about 14.4 decibels. So from here, we're going to what I consider my basic standard product. This is the first one I tested, and so far it had been the highest performing. You notice there's a drop in the actual frequency of the resonance, but then this one has about an 18.3 decibel reduction in amplitude of that resonance. So that's why it's our standard as of right now, up until this test. So from here, I'm going to the new Resonix product. This is Resonix Mega. This has the thicker constraining layer. It's a little harder to read because it's flattened the resonance peak so much, but this one has about a 21.1 decibel reduction in the amplitude of resonance. It also flattened it out quite a bit. And it'll kind of make a little more sense when we get to the waterfall plots. Now, this green plot is Resonix Mega with a 3M constrained layer damper applied dead in the center on top of this. It's a special product. There's no beetle in it. It's a stainless steel product with an adhesive layer that claims to be viscoelastic. We're also going to test that next, but it did make a noticeable difference. And at this point, it actually removed that initial resonant frequency, and the resonant frequency is now lower. This is the Audio Additives on its own. This is that 3M product we just talked about. And it's about a 9.2 decibel reduction in the amplitude of resonance. This is a 15 mil thick stainless steel with a viscoelastic adhesive, and it's marketed towards amplifiers, stuff like that, high-end home audio type stuff. It actually did a better job than I thought, considering the product is only 4.5 inches by 4.5 inches. Now, these are the interesting parts. This is a waterfall plot, and what this does is it basically shows you the frequency response over time. So essentially what we're looking at here is 100 milliseconds. So how much the frequency response actually decays over 100 milliseconds. In the very back is the initial impulse response. The very front of this, which you can see it going to now, is 100 milliseconds later. So as you can see, any of those high peaks that doesn't really drop down too much is something that's going to be ringing out for a long time. So this is really important, considering this is 100 milliseconds. Sound quality vehicles, sometimes we're adjusting things down to a 1/10 of a thousandth of a millisecond to get time alignment correct. And you can see, outside of slight variations in the frequency, almost all of them look the same for the untreated metal panels. So this is what it looks like when it's treated. You can notice that peak is actually decaying quite a bit faster. This is the Tesla product. So at 100 milliseconds, the resonance is down by 21.6 decibels. So like we talked about before, at impulse, it reduced it by 9.5 decibels. 100 milliseconds later, it's down by 21.6 decibels. So it makes a bigger difference. It's not ringing out as long. There's a reason I don't go past 100 milliseconds, which we'll get to later. It makes it hard to compare certain products. But we're going to move on to the Digital Designs product. And as you can see, it actually drops a little bit faster. So again, this one had an initial resonance reduction of 13.3 decibels. At 100 milliseconds, it's now 28.1 decibels down. So significantly better than the Tesla. We're going to go ahead and move on to the Vibrofiltr 3mm after this. And real quickly, you can see the difference in how each one is actually affecting it over the time domain. So this is going to be the DD versus Vibrofiltr. You can see it's a smaller difference. There was only a 1 decibel initial difference. But if you look, despite only being 1 decibel better than the DD, it's actually 32.7 decibels down at 100 milliseconds versus 28.1 for the DD. So now this is Resonix. This is why we don't go past 100 milliseconds. If you notice, it's almost into the noise floor when you get to 100 milliseconds. So anything past that, it would be very hard to do. It is 44.9 decibels down by 100 milliseconds for the Resonix. So again, this is why I considered it my reference product up until now. This is Resonix Mega. This is even further down. At 100 milliseconds, it's 46.2 decibels down from the initial impulse. So again, it is a bit better of a product than the regular Resonix. It's not a huge difference, but if you're going for everything, it does help. Now, this is the response with that audio additives / 3M product added on. It's a 4.5 by 4.5 inch square added to the dead center of that product. So with that audio additives added on, you are 50.7 decibels down at 100 milliseconds. So now we're moving on to the audio additives by itself. And again, it looks very similar to the Tesla product, but it is slightly different. It's 21.2 decibels down at 100 milliseconds. So it's not quite as good as a Tesla product, which the Tesla product surprised me for how it felt. But it, being a 15 mil thick sheet of stainless, it's pretty good. So I'm gonna go and do another video later on going more into depth about how to really look at these. Because this is really more important than just the number itself that we get from frequency response. The faster it decays, the less muddiness you're gonna have in mid-bass, bass, things like that. I've got some other measurements that another user sent me showing before and after they did their roof. and they still had ringing after a second and a half. So really quickly, the rest of this is just going to be going over the entire test process. If you want to watch the rest of this video, go ahead. It is going to be over an hour long, but this is uncut from the actual testing section showing the entire test. So there's going to be more coming up soon. So again, if you want to stay up to date with everything, go ahead and just subscribe, and we'll get you more videos as soon as we get them done. Thanks. All right, so this is supposed to be the stuff that is supposedly installed on Teslas from the factory. This was randomly sent to me out of nowhere, but that's what I've been told it is. I have no way of proving it is or isn't. That's what we're going to go ahead and go with for this, because I have no other information. So it's about 68 mil thick with the backing paper. It's pretty floppy, as you can see. Backing paper's 6 mil thick, so total thickness is about, we'll say 62 mil, which I'm going to write down real quick. I'll measure the aluminum thickness once we get it off. We're going to go ahead and weigh. And it's coming in at 45 grams without the backing paper, so that's what we're looking at for that. All right, so we're going to go ahead and get this put on. We're going to test this, remove it, move on to the next. Next is going to be the Digital Designs deadener. Aluminum appears to be very thin, with just enough pressure to make sure that it's fully adhered. It's still deforming the aluminum layer on it. Let's see. So as for performance, we're looking at 5.9. About a 9.5 decibel drop in performance. So that's actually better than some of the stuff sold on Amazon right now. It's better than some of the products like Killmat and stuff like that. It's better than Silas. But we're going to go ahead and get that removed and move on to the next one. Okay, so it comes off relatively clean. We're going to go ahead and peel back some of the butyl so we can get a measurement on just the aluminum itself. Which is pretty difficult to do on this one, actually. Okay, makes sense. It's about a 2 mil thick aluminum. It makes sense why it's so floppy. So I'm going to write that down as well. All right, on to the next, which will be digital designs. We're going to go ahead and run 2 coats of alcohol just to be safe. Last time it had already been cleaned and it just sat for a while. Now using the alcohol does change the temperature of the panel, so we may have to let that equalize before we run our next test. Actually, it looks like we need to get it a little cooler. So the next one is going to be the digital designs, DD audio. This one we're going to have to measure in 2 different places because it is a textured piece. You can actually see that texture
And if you hold it sideways, you can see the texture in both sides, the front and the back. So we're going to do several measurements. So in the thinnest area, we're getting 90 mils. When we go crossways to those ripples in the back, we're getting 112 on the low spot and 140 on the high spots. That's before removing the paper, so we're going to remove the paper and measure that because that's adding to the thickness. And as you can see, ripples in the product, just fully transparent. I don't think that's going to help its performance. And the thickness of the paper, significantly thinner than the Tesla stuff. It's right. We're gonna give it the benefit of that. We're gonna say 3 mils. It's about 3 1/4. So that brings it to 87, 109, and 137 for the sections that we measured. We're gonna go ahead and get a weight. So we're looking at 94 grams. All right. So we're going to go ahead and install this. So for anyone that can't see what I'm doing, there are the crosshatch lines here. I line up the corners with those crosshatches. That's how I get these lined up. This is one of those ones that say to make sure it's flat. I'm not going to press any harder than that. That's about as flat as it's really going to get. Go ahead and measure that. Okay, so that's significantly better than the Tesla stuff. I would hope it would be. All right, so we're looking at so it performs well. It's not anywhere near the top, but we're right at about 13.3 decibels of reduction at the peak amplitude point of the resonant frequency. So go ahead and get this removed now, and and move on to the what is it? Vibrofiltr. Vibrofiltr, whatever, however you say it, without the E in there. And then once I remove the DD, we'll check the thickness on the aluminum. Okay, so I automatically wonder if this is made by the same place that makes the Amazon, because it performs extremely similar. And Amazon is the only one where the aluminum has peeled off completely and just left the aluminum or the butyl still in the rig. So I'll get a flattish area for this to measure. So I'm getting just over 4 mil. We're talking like flatten this a little bit. We're going to go ahead and call it 5 mil. It's right at 5 mil, so. All right, this is fun. All right, that is not going to come off with just alcohol, so we're going to use Goo Gone and several passes with alcohol to make sure the Goo Gone is removed. Which means I'm putting on gloves for this. Make sure we're still recording. Okay. Even seems to come off the same way as Amazon. So I'm not saying this is made by Amazon, but if I was betting, if I was a betting man, that would be what I would assume. So again, the next one's going to be the Vibrofiltr. That one's also a textured product, so we're going to have to measure it in multiple locations. It doesn't seem to have the same issue the Vibrofiltr or the DD does, as far as having the backside. Oh, it's got a little bit. So yeah, even on this one, the backside's still a little textured. Also, it appears to be stained. It does seem like there might be something more than just straight butyl in there. I, again, can't say for sure without testing that is way out of the budget, but it does seem like there is something other than just butyl in there. Usually the ones that stain have sort of an asphalt smell to them or a bitumen smell, and this one did smell like that when I got it in. All right, so we'll go ahead and start measuring on this one. So in the low areas, it seems to be, we're going to say 102. Yeah, we're going to say 102 mil. On the high areas, we're looking at 138. All right, so give me a second. I'm going to get a weight. All right. So paper thickness, 4 mil. So we'll go ahead and remove 4 mil from the measurements of overall thickness. Brings it down to 98 and 134 for overall thickness. And then weight. $102 grams. All right, so we're going to go ahead and get that installed. Run this one. Go ahead and put the logo up just because. This is another one with dimples, another one where the instructions say roll it flat. This one does not appear to roll as flat as easily as the DD did. In fact, I don't think I'm going to be able to get it flat. I'm not going to heat this. I don't care what the company say. There's no reason to heat a butyl product above room temperature. Anything you do that heats it above room temperature, using a torch or a heat gun or anything like that, risks damaging the product. If anyone wants to call me out on that, before you do, contact the manufacturer and ask them what chemical process makes it perform better, or what mechanical process makes it perform better after it's been heated. All right, so we are looking at so a little bit better than the DD, 14.4 decibels is what we're looking at. I would have to check, but by memory, I think that's pretty close to the third best product I've tested so far. So that was 14.4. So let's go ahead and get that pulled off. We'll move on to the reference products that I'm using for reference on this. Now the reason I'm using these as reference products is because lately there's been one person in particular. Wow, that came off easy. And as you can see, I was pressing hard enough to basically flatten these. But if you, and like I was pressing hard, not everything actually attached. And unfortunately, I wasn't able to tell that on the DD, but I have a feeling it was the same way. It looks like the manufacturing process has an issue that causes these dimples on the back. Realistically, that's just a bad design decision. This should be flat. It should not be dimpled. The physics behind how constrained layer dampers work make it very clear that these should be flat, not dimpled. Later on, I'll try another test, see if I can get it any flatter, but I was pressing hard enough that I would be concerned of doing damage to the sheet metal in an actual car if I was doing this. That's, to me, a bad design decision. So, and realizing I didn't get a picture of the weight of this, I'm going to go ahead and get that now. All right, so we're going to clean the panel again and move on to the next. So the reference material is going to be regular Resonix. This is the, not this one. This is the original Resonix. It's the 4mm aluminum layer. The reason I'm using this as the control for this is because the person that's been promoting Vibrofiltr on the group has been consistently stating from the beginning that Vibrofiltr is just as good. It performs the same. The damping factor is going to be the same. So that's going to be what we compare it to. It looks like we're also going to need some Goo Gone for that residue. So that's why we're using it. That's why it's going to be the control. We're then also going to do the test of the Resonix with the thicker aluminum, and we're going to compare that. As right now, that is the highest performing product I've tested. Now, one thing we didn't do real quick was get the metal thickness of the Vibrofiltr. It's we're going to say 4.25 mils. It's consistently above 4, but it's very, very, just barely above 4. 2, yeah. We're going to say 4.25 just to get that done. So this next one is going to be Resonix once I get this cleaned. Then we'll do Resonix Mega. And then I've got a special one that I've been holding on to for a while. It's actually the most expensive product I've ever laid my hands on. Is a 3M product, supposedly. Sold by an audio website that recommends it for use as a constrained layer damper for damping electronics vibrations. It is $60 a square foot. I've actually had it for several years. I've been wanting to test it for a while. We're going to go ahead and just do that today. It's not going to be a fair comparison. I will have to do another test later to compare what other products can do with the same coverage, because the widest this other product comes is 4.5 inches. So instead of the normal 5.5 by 5.5 sheets, we're going to do 4.5 by 4.5. And then I have a special test after that that I want to try as well. Something I've been wanting to do since the original test I did back in 2013, 2014. Okay, now I'm going to give a disclaimer because this is just one of those things that is what it is. The original regular Resonix that I have is 4 years old. And it has lived in my garage pretty much since I took delivery of it. Okay. So, like I said, there are two products I got in right when I started building the test rig before it was fully built. One of those was the original Resonix. The other one was Road Stage Audio. Anyone who's been in the group long enough knows that Road Stage just closed out their product. I know that was a side project for the owner of that company, but that project is closed out now. So I don't actually have enough of that to test, however. All right, so I'm getting right about 120. We're going to say 118. What I'm measuring is 118. So 118 mil thick before the actual paper is removed. So we'll remove the paper, check weight, check paper thickness. We'll apply it. This stuff is consistently a pain to get off the paper at first. So I did want to show this. Notice that it's pretty much flat. There aren't any dimples. You're basically more likely to get a full attachment to the actual metal panel. Okay, paper 6 mil thick. So we'll say it's 112 total. And weight. Right at 94 grams. So we'll go ahead and get this installed. Make sure this is still recording. Yep. Okay. All right, we're gonna go ahead and test this. Again, full transparency, I didn't press down as hard on this, but being that it is flat to begin with, there isn't a reason to. All right, so remember, this is the original Resonix, the one that's supposed to have a 4 mil thick aluminum layer. Give me a second. I'm going to zoom in on this because this does not appear correct. Could be, but Okay. Well, it is what it is. This is actually the best I've ever tested it. 18.3 decibels. It's noticeably higher than in the past, by about a decibel. So I'm actually going to pull this off and make sure that I'm using the right stuff. So it's more difficult to pull off, but it comes off about the same as terms of how clean it comes off. I'm going to clean off some of this butyl so we can get, yeah, this is the right stuff. Okay, so I'm not getting 4 mil, I'm getting right about 5. It's just under 5. We're going to call this 4.65 or 4.75 actually. Yeah, the weight was 94. And that was 18.3 dB. All right, we're gonna get this cleaned up again. We're gonna go ahead and test the next one, which is Resonix Mega. That is the newest with the thicker aluminum layer. I have measured it on the test rig. I have not physically measured it, so we'll get that done. It's supposed to have I believe a 12 mil thick aluminum layer. So we'll check on that. As of right now, the Resonix Mega has tested better than anything else I've tested. Specifically, I did the test of multiple layers of Kilmat and Noico versus 25% coverage with the Resonix products, because that was asked for many, many times. And at that point in time, it was the highest thing I've ever tested. It was over 19 decibels of reduction at the resonant frequency. So again, we'll get this cleaned up. We'll measure that one, and then we'll get on to the additional product that we're going to test today. All right. Okay, so this is Resonix Mega. This one has not sat out in the garage. It was sent to me more recently after I cleared up room for stuff to be stored in the house. It's coming in at 129. Okay, yeah. Consistently coming in at 129 mil for total thickness. I'm going to assume it uses the same paper, but we'll measure it anyways. And then we'll get weight, and then we will install and test. Again, you can see no real dimples on the back. $108 grams. And get a picture of that. 109 actually. Okay, we'll go with 109. And paper thickness is the same, 6 mil. So, we're gonna go ahead and mark this down at 123 mil for total thickness. All right, get it installed, measure that. And then before we do the last one, there's an experiment I actually want to do with this that, again, like I said, I've been wanting to do for over a decade. So we're gonna get that done. Okay. All right, so for Resonix Mega, we're at 21.1 decibels. Again, noticeably higher than the last time I measured it, but still the highest I've ever measured. Even the last time it was still high 19s, it was like 19.6, I believe. So 21.1 D, and then we'll go ahead and actually, before we pull that and measure the thickness, the test I've been wanting to run for a long time is seeing the effect that a thicker constraining layer has on a already known product. So, for instance, take a product, attach an additional layer to it to stiffen up the constraining layer a little better and see what it does. So the product I'm holding right here is that 3M product that I talked about earlier. I'll put a link to where I bought it from, all that information. But like I said, this stuff comes out to $60 a square foot. It is 15 mil thick, supposedly. We're going to find out when I measure it. 15 mil thick stainless steel with what they say is a viscoelastic adhesive layer. There's no butyl, there's no asphalt, no nothing. They're basically stating that the adhesive layer itself is viscoelastic. So what we're going to do on the piece that already is on here, we're going to attach this straight to the center of that and remeasure to see what that does to the performance. And again, I don't know what it's going to do. It's just an experiment I've been wanting to do for a long time. So I'm going to get this pushed down and adhered. And then, like I said, we will test that on its own as well. So, okay. Almost nothing. In fact, it actually, I know, I mean, it did do something. It didn't do much, but it did do something. So, we're going to go back. So it actually reduced it enough where the old peak and frequency response is no longer the peak. There's actually a section lower in frequency in the 60 to 70 hertz range that's now higher. But the original frequency response where that resonance was, it gained a little more than a decibel. So 82.5 is what that did. So supposedly 15 mil of stainless steel only gave you an extra decibel. All right, so we're gonna go ahead and pull that. We're gonna measure the aluminum thickness on the Resonix Mega, and then we're gonna test that stainless product on its own and see what it does. All right, so let's peel this back from the edge, get this measurement done. Yeah, so I'm measuring just a hair over 12. I'm measuring right at like 12.25 mil. And this actually is really stiff with this stainless layer on here. Okay, so 12.5. Or 12.25. All right. Last one is going to be a 4.5 by 4.5 inch piece of the stainless steel material on its own. And then I'm going to go ahead and shut off filming after that. This will go up later on YouTube, primarily unedited, just because I've had too many people accuse me of trying to be biased. I've had too many people trying to accuse me of benefiting from this testing. And to be honest, I couldn't care less who actually performs best. I just kind of want to know. Last time I made the mistake when I first did testing in 2013 of making a bunch of statements before testing, thinking I knew exactly how it was going to go. And it was made to look real stupid. So this time, what you get is what I test. I don't make claims ahead of time. I just test it and give you guys results, and they are what they are. So coming up in the next week, I'm going to get to some of the more asphalt / thermoplastic type materials. We're talking Sundown. What is it? Vibrofiltr. We'll get some of those tested. Those are much more difficult because those require heat to be installed. And because temperature has a big effect on how these products perform, we essentially have to do the test of the bare panel, install it, and then cool it back down to the same temperature it was when we did the metal test to have any kind of realistic results. Because if we were to test it while the material was still hot, it wouldn't be a fair comparison. So right. So it's coming in right about 20 mil thick with the paper on. Get this paper off, weigh it, check the paper thickness. 27 grams is what this stuff weighs. And paper thickness is right at 5 mil, so it is 15 mil thick as advertised. So and 27 grams. Not going to be a way to measure it with and without the adhesive. My estimation is the adhesive may be half a mil. Can't really see where it begins and where it ends. We can go ahead and get this installed in the center. Hold on. Again, keep these results with a grain of salt. I will have to do some testing later with other products to see what it compares to at the same coverage level. But for now, it's just something interesting to screw around with. Okay. Okay. So, let me get my calculator. Better than I expected. So 9.2 decibels. I really wish they sold this in a bigger size at this point in time, because it would be interesting to see what it did apples to apples compared to the 5.5 by 5.5 inch sheets. But for now, this is what we have to work with. So 9.2 dB. It's what I'm mostly concerned about now is how I'm going to get this off. But for now, that's going to be it. Like I said, this will go up on YouTube unedited. There'll be a full write-up on the Deadening Facebook group. And pretty soon, we're going to have full product reviews coming out. Should be hopefully within 2 to 3 weeks. I had a couple things happen, waiting on a car to be released to us since our old car got totaled out, on top of work things. However, it will be coming up, so we will get that done as soon as possible. And we'll try to get you guys more stuff quickly.